So let's go to slide okay, let's go to slide 6. mm, mm, Question 8. Oh, okay, can you see the question already? Good. Try to attempt it on your own first. What's the formula for the uh, equation of circle? Okay, so that's the reason why it's important to know the basic stuff first. So what's the basic stuff for the um, equation of circle is the general formula for equation of circle, right? Okay, so mm, so what is it? The point da 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 are on the circumference. So basically, you have this circle, and then you have the 1 and 10, 1 and then 10, and then you have the 7 and 10. Okay, so it looks like you need to do a sketch. It might not be the right sketch, but it need to be somehow give you a idea how it looks like. Okay, so let's say 1 and 10, then 7 and 10. What do you mean? Like which one you are looking at now? No, no, the circle, right? The circle looks like this, right? So this point and this point can be the same. That's why it's here and then it's here. Okay, yeah. And then it says lies above the x-axis, so it should be above the x-axis. So my circle is not so correct, so I have to redraw it to fit the description. Let me see. Center C lies above the. Oh yeah, yeah, yeah. That means I am correct. You know what I'm thinking? Uh, yeah, yes, 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 yes. So I need to read the question carefully. Yeah. Okay, so the center is here. Okay. So yeah, that's good. Okay, so if I remember correctly, the center, okay, the center is the x and y. So if I remember correctly, the formula is x minus, uh, okay, I call this the center x and then the center y. So minus the center x, I mean, yeah, square plus the y minus the y center y is equal to the r square. R is the radius. which is this. Okay. Then now, so it's tangent to the circle. So in a way, right? Yes. So in a way, I have to get it into the above the. Okay. So yes. So I still have to redraw it. You know. Yeah. Cool. Actually, it's better to use PowerPoint, but anyway, never mind. Just bear with the ugly drawing here. Can I get a circle? Yeah, I can get a circle here. Yes. Okay, never mind. By the way, these days I seldom do the online meeting already or online lesson already. I do face to face already. Do you still do you go to any tuition center and have your lesson there, or you do mostly online? Okay. So besides mathematics, what else you are doing? Okay. Okay, so then this is the thing. Okay. So this is the x. All right. And this one, so this one is okay. Yeah. So, how? So okay. I'm trying to ask how you do this question. So this is general formula. Okay. So yeah. Okay. Eh, hmm? Can you use the midpoint? Meaning this one. Hey, why I erase it? Sorry. This one. The midpoint will get the this point, right? That will give you the xc, right? Right. Then we will care about that later. So this point is your midpoint theorem is 1 plus 7 over 2, then 10 plus 10 over 2. So that will give you 8 over 2. Then this will give you 20 over 2. So it's 4 and 10. So I know that this point is my 4 and 10, right? So by the way, I think you already know this point. This is 4 and 1. This one. And then therefore this is your 4 and YC. Right? Okay? So once you have this, then I think you can solve it already. This is 4. Right? Then you just sub in one of the this is 4. Then you can use this point, right? You use the distance formula. What do you mean by use the distance formula? Yes. 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 Actually, the other way to look at it is this. Okay. The other way to look at it is this radius, right, is equal to this radius. Is this radius. Okay. So how do you get this radius? This radius is your x is, so your x here is, so you take 4, right, and then you take 1 minus yc, or you can take yc minus 1, yc minus 1. Okay, and then this one should be equal to 4 minus 1. Then you take yc minus 10. Okay. Okay, so basically actually if you take 1 minus yc, then you have to take 10 minus yc later. Yeah, so what I'm trying to say, right? Okay, hold on. If you take, okay, what I have done here is I take this 4 minus the 4 here, and yc minus the 1. So I need to do the 4 minus 1, and then yc minus 10. So I always take the center point minus the point at the circumference. Okay? But you were trying to say, can I take the circumference point minus the center? Yes. 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 So later when you, let's say if you do the let's say you do the circumference point minus the center, you need to use the circumference point minus the center. Just to be consistent. Okay, then this is a one equation and then one unknown. Okay, then if you solve it, right, I think you use, okay, this one is 0. This one is yc. Actually, I'm using the length to length. It's just like, can you see that this is the length equation? We just did it. Yes, we just did it just now, right? Yeah. Okay. Because, okay, we don't need the square root, because this is our, when we do this is our r square, radius square. Okay. Okay. Yeah. Okay. So that's all. If you figure this out, your yc will be equal to. In fact, we did this just now. Okay. So we're making use of the length equal to length. Okay. So yc is equal to 6. So that is why it's 4 and 6. Okay. Then now find the equation of the circle in the form third where okay, good. So how do you transform this into this format? So you start with this completing square. I think you just open up, right? Open up, hold on now. So y minus 6 r square. I think you got your r square already, which is 5. The radius is 5. Okay, because once you find the yc, right, once you put it in, then you get the, this is 5 square, right? So it's, the r is 5 square. So this is the formula, okay, for the equation of the circle. Okay, so with the equation of the circle, then yeah, you just expand everything, right? Yeah, so you expand everything, minus 8x plus 16 y squared minus 12y plus 36. Then you even need to bring this, then you just by comparison later on. I mean, this is also one way, yeah. So x squared minus, so plus y squared, this one is gone. So I have 8 minus x, hold on first, minus 12y. Then this one, so it's 52, 2 minus 25, so this is what? This is 27. So just read the thing off. Okay? Okay? So this is by comparison. Because just now you talk about completing square. I have not done completing square here. Did I? No, right? Just by comparison, right? Okay. Actually, completing square is also by comparison. Let me show you. Okay, after this. So find the equation of the tangent to the circle parallel to the y-axis. Find the equation of the tangent to the circle parallel to the y-axis. I thought y equals to 1 is one of them, and then the other one is here. This point is where your where it's 4, but the radius is, but the y don't know. This is the y circumference, or the y parameter. So how do you get this point? Yeah. So x minus 4. Oh, then you have the 4 here already, right? So you have the 4, you put it in. This 4, you put it in. Then you have the square, and then you have the yp. So you use the 4 minus this, then you need yp minus the center, which is 6 square. You get the 5 square. How do you get 5 square? Yp is 11, right? So that's 11. Wait. No. Am I right? Oh yeah, that's also possible. That's also possible because this is 5, right? This is 5, right? So therefore your this is 6, right? 6 plus 5 is only 11. Yes, sure. Yeah. Okay. Oh no, they want it parallel to y-axis. That means here. Not the x-axis. Okay, but never mind. So I have found something. So that y-axis is this. So you need to find this. Okay. So need to be 5. Yeah. So 5 away from the 4 lah. 5 away from the 4. So this is x equals to 9. This is x equals to minus 1. Okay. So in fact, I have found everything. So whatever the question asks, you just give it to them. Okay. Okay, so just now I talked about the, let's go to slide 6. Just now I talked about the completing square is as good as so what they normally do, right? They ask you to express in this format, given anything, like let's say given no, let's make life easy for me. Okay, let's say you are given this. Okay, you're given this and you are asked to express it in this format, right? And you know it's about completing square, right? Slide 6. Yeah. So let's say uh so you are given this, okay, given, and you are asked to express in this format, okay. So what they are asking you to do is actually you need to do completing square, right? And actually a lot of students, right, maybe for express students and or maybe students like you, you know that, hey, I know what to do is like 6/2, right, something like this, right? So this is 3, and then you know that, hey, I have this 3 square which is 9, so I just have to plus 3, right? So that's the completing square format, right? Okay, good. So this question is slightly easier, but what if you get questions like this? Maybe this, and it gets more complicated, right? Right. So in a way, right, actually I also suggest there is another way to look at this question. So what I will do is, instead of doing completing square for this, I will expand this. Okay, let me expand it. And what I will do, I'm doing by comparison, if you realize. Okay, so okay, then this is my A. Then if my A is this, so 219. So you just have to use your calculator, then you get your B lah. Make sense? It doesn't matter. It will take care. It will take care of itself. Let's say it's minus. It will take care of itself. No, the thing is, it really depends. If this is plus, it will be plus. I mean, if this is plus, it will be. This is plus. This will be plus. I mean, it will take care by itself. Okay, never mind. Let's go to slide. Let me just give you another example. No, this is not the. Okay, this is in completing square format already. Yeah, something like this. Okay, so I know it's definitely minus. The plus b or minus b, right? It doesn't matter. It will take care. It will take care itself. Okay. You know what I mean? So basically, you just do this. You help me out a bit with your calculator. Okay. So your this is your this. So your minus 2a is equal to minus 419. So your a is equal to then your this is so b is equal to 1 minus 81. Yeah, so 81, so 77 or 81. Okay, then you just plug it in. It will take, I mean the sign will take care of itself. After you, when you do the calculation, the sign will take care of itself. Okay? Okay? Actually, I'm not too sure whether the completing square formula actually derived from this method. Maybe it's another variant of this method. Yeah. But they try to just maybe the school teacher, they say just memorize, okay? Don't ask me why. Just memorize. Do it this way. But actually, a lot of students, right? I try to teach them completing square, right? They are quite confused. They are wondering why divide by two, and then like if you divide by two, and then you have this term, and then you have to square it, and then you have to account for that. They are just confused. But with this by comparison method, it's less confusing to a lot of students. Okay. So hopefully you see how I, for the part 2, right, I did not use the completing square, but somehow I still managed to use by comparison to get the P, the Q, and the R. Okay. Okay. Good. Good. Okay. One more question on poverty of circle. Oh no, I mean not poverty of circle, but circle, equation of circle. No, not yet. I need to get the upload. Upload the. Mm. But I think this question is also a similar, just similar lah. They're so similar. The slide 8. Okay. Hold on. I lost the question, so I need to read. Maybe I should see how you do the. Maybe instead of the circle question, I should take a look at your this kinematic. Are you good at kinematics? Yes, but you should be looking at slide 8. Yes, but the thing is, when it comes to kinematic, right? You know the displacement and the distance, they are two different things, right? Yeah, from the origin, yes, yeah. Then distance is yeah. So let's take a look at question 10. You should be at slide 8. So with this, I think we had a very good discussion today. Okay, so let's. Not yet. I already clear up a lot of stuff. Maybe it takes a while for you to look. Okay, so how you do this question then? Question 10. You are given the displacement, right? Yeah. Oh, the distance. Sorry. In the meter is it? Oh no. A particle travels in a straight line from a fixed point O, where the distance from the O. So this is displacement. Yeah. Okay. And you are asked to find the what? The velocity particle. Okay, it's 20. Okay, good. I think the first question is giveaway. So given the displacement, so velocity is ds dt, right? So how do you okay, maybe I just demonstrate to you the way I do differentiation and integration. So hopefully you take a look at my approach, and if my approach is somehow easier, maybe you can adopt my approach. So what I do is I bring down the power, bring the power to the front, and then power minus 1. So similarly, bring the power to the front, and then power minus 1. Okay, then this one, bring the power to the front, which is 0, then there is minus. So basically this is Q, or nothing. So QT, when you differentiate QT, you get Q, right? So therefore you just get 4t to the power of 2, sorry, plus 2k, t plus q. Okay, so far so good. And then now what you do, then you say the velocity when it passes O is this. It passes O, that means t equals to 0, right? So therefore you just sub in t equals to 0, then it's equal to 20. So therefore your Q equals to 20, right? So that's why you get 20. Okay, and at t equals to 3, its acceleration is 0, so you need to differentiate this one more time, right? So you differentiate your this dv over dt, which is your acceleration, then you differentiate one more time, you get 8t, then plus 2k, right? Velocity, you get acceleration. Yes. 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 Why you are asking me this question? I thought this is the most basic one. Yeah. Yeah. Or you have not done this kinematic for quite some time. That's why you have forgotten. Good to have some revision. Yeah. Okay. Good. So when the t is equal to 3, acceleration is 0, right? Just sub it in. 0, 8 times 3 plus 2k. So minus 24, 2k. K is minus 12, right? So k equals to minus 12. Okay? Now, find a value when the particle is instantaneous at rest. What's the meaning of instantaneous at rest? No. Instantaneous at rest, I thought is when the velocity is equal to 0. Yeah. So instantaneous rest means velocity is 0. When acceleration is 0, right, it means there is no change in velocity. It can be 20. I mean 20 meters per second, and then 20 meter per second. There is no change in velocity. Then there is no change in acceleration. But that doesn't mean at rest. Okay. The velocity can start from velocity initial can be 20 meter per second. Then the v final can be also 20 meter per second. So in a way there is no acceleration, but there is velocity. So that's the reason why instantaneous at rest is v equals to 0. Okay, so when v is equal to 0, then you just have to get the, so it's 4t squared. So your v is equal to this plus 2kt. K is negative 12, so it's negative 24 t plus 20. Yeah, so we erase the rest. So you just have to equate the v equals to 0 and you solve this quadratic equation. And do you know that you can use your calculator to solve the quadratic equation fast? Very fast. Yeah, so what's t in this case? So you don't have to do the factorization method, or you don't have to use the formula and all those. So t is equal to, you are supposed to get 2t. Yeah? Good. And do you know why you need to find instantaneous at rest? Now, okay, so let me go to slide 9. Okay, so when a particle goes this way, right? Let's say the particle goes to the right. Slide 9, yeah. So you go to it goes to the right. So if it never stop means velocity 0. Okay, so it will always goes to the right. Okay, so if it stop, you know what I mean? When it stop, there is a chance it will make a turn. There is a chance it will make a turn, but that doesn't mean it will always make a turn. There is a chance it will make a turn. Okay, because when you make a turn, you have to stop to make a turn, right? I mean, there is a chance. There is a chance. But of course, the particle can stop and then move forward. That's another possibility. This is one possibility. Make a turn, and this is another possibility. It will continue the path, right? Okay. Okay. So that's the reason why we want to find out when when it is at rest, so that we know that whether this particle move forward, continue the usual path, or it makes a turn. So what we find out is when t is equal to 1, right, it rests, and t equals to 5, it rests, right? You don't sound convincing. Are you convinced? No, it has to stop. But now my question is whether it continue the usual direction or it make a turn. That's what I want to know. Because that will affect the distance. That will affect the distance. It really depends. So later I will draw it out so that you can understand better. Okay? So now let's go back to the displacement. The formula is the so you have to get the you have to get it get the particle path sketch out. Okay, so t equals to 1 at rest, t equals to 5 at rest. So this is the displacement formula. So displacement at t equals to 0. So your displacement, if you sub it in, can you help me out? So what's your displacement? So it's 9 and 1/3, right? Meter. So at t equals to 5, negative 33 1 over 3 meter. Okay, and then let's look at the question again. So it says find the total distance traveled during the first 8 seconds. The first 8. Can you see the first 8? Can you go to slide 8? Yeah, they asked for the first 8 seconds, right? So they asked for the first 8 seconds. So I know that, can you go back to slide 9? So I know that at t equals to 1 at rest, at t equals to 5 at rest, so the final one will be t equals to 8. So where's the displacement? So later I'm going to draw this particle path out. So then only I can get the total distance. Okay, so it's 74 2/3 meter. Okay? Okay? So now, so the particle at t equals to 0 is at the origin, right? Okay, so let me just draw it somewhere here. And at t equals to 1 is 9 1/3 away. Okay? And then at t equals to 5 is negative 33 1/3. So that means it's here already. So I need to extend that a little bit more. Okay, let me write it below. Okay? And then t equals to 8. Oh! Come back to this. So I need to make it this smaller. Then t equals to 8 is so far away. So I need to, this is 1 point, and this is another point. And then of course, need to go. T equals to 8. So therefore, with this, then you need to sketch the trajectory of the particle out. Okay, so I think you have no question about the first second. It should go to 9 and 1/3, right? And then t equal to 5. That means from the 1 to 5, right? It make a turn. It make a turn and travel to here. Am I right? And then after, I mean between t equals to 5 and t equals to 8, it go all the way back to the origin, and then somehow extend to this. Do you agree? Do you agree this is the trajectory of the that's the total distance traveled by the particle? Okay? Yeah, so basically is this is 9 and 1/3. Okay, and then it travel another 9 and 1/3, which is here. It travel another 9 and 1/3. So basically I use a different color. So 9 and 1/3. It travel another 9 and 1/3. So 9 and 1/3 plus 9 and 1/3. And then it travel, this is 33 and 1/3. and then come to 33 and 1/3, right? Right? And then from here to here is another 74 and 2/3. This is the total distance. Am I right? Yeah. So what is the final answer? Help me out. Very good. Yep. So the answer is 160. Okay, looks good. So that's the total distance traveled. Have you encountered this kind of question before? Did you know how to do the other time? But it seems to me like the distance travel like this, you are a bit surprised. Oh, that kind of thing. Wow, I mean, if you know how to do it, then you shouldn't be surprised. Like, oh, this is the way to find distance. Okay, so it's important to note down the point where it stopped, because like I say, when it stops at instantaneous at rest, there is a chance it might make a turn, and in this case, it makes a turn. Okay. Okay. All right. So yeah. So I think today we had a very good discussion. We talk about this question, kinematic. Then of course we talk about circle, like equation of circle. Then yeah, you can actually do the by comparison to get your uh, this I'm actually at slide 6. I'm trying to look back at what we have learned so far. So the by comparison to get the competing square out, right? Instead of memorizing the formula, then yeah, we do a, this coordinate geometry. Okay, making use of the length the same length which is here, done by you. Okay, same length. And then I ask you not to memorize the formula to find the length between 2 points. I ask you to somehow come up with the formula on the spot if you cannot remember, right? And then the midpoint theorem, and then of course the shoelace method to find the area of that this I think is looks like a rhombus to me. Okay. Then of course we learn how to get the ABC out. Okay, the ABC out for the curve given in this question. Okay. Then of course we prove the left hand side and equal to right hand side, and I demonstrated to you somehow you need to do a bit for the RHS before you can see how you can actually not uh, do anything to the RHS, but you still can prove that they are equal, left and right, right? Okay. Then of course then the last one will be this question on binomial expansion. So there is no independent term. So how I prove to you, like in order to get the independent term x to the power of 0, our a will be 3.75, right? So 3.75 cannot be, I mean 3.75 is not a whole number, and a must be a whole number, right, in order to be valid, right? So therefore, since a is not a whole number, so therefore a is not valid, so a is not valid, so therefore we can't get the x to the power 0 term, right? Okay, then of course we talk about um, I think, yeah, I think this answer most likely right. Okay, I just look at the formula sheet, and then my this is uh, my this using the formula and expand it out and then simplify, I think is correct. Okay, but you have to use it more often, and then including myself, I have to use it more often, because if I don't use it more often, then it'll be a bit rusty for me also. If it's rusty for me, then it is more rusty for you as well, right? Okay, so next week, before, I mean next Friday, so I will give you a question on binomial, a question on a proof, a question on this coordinate geometry, and then um, equation of circle, and then kinematic. So basically what we have talked about today, okay, like about 8 questions. All right. Okay, so basically that is our materials for next week. But of course, if you have your school materials, if you want to ask me, please go ahead. But I think I have already prepared you well for your binomial expansion topic. Okay, so you should be having a good time in school learning binomial expansion. Okay. Okay. Any other question for me before we conclude today? Okay, good. So yes, so thank you for your cooperation, and yeah, see you next Friday, and be on Zoom 5 to 10 minutes earlier. Yeah. Good. Okay. So see you. Bye bye. Thanks. Bye bye.